Hi everyone. Today I will show you how to make another beautiful compound. This time it has a blue hue and it also is very historically renowned. Today I will show you how to make iron hexacyanoferrate, also known as Prussian Blue. Prussian Blue is best known for its deep blue hue. It is commonly used in many forms of art. Most of you will have heard of Van Gogh's Starry Night or The Big Wave, and they both utilize Prussian blue. It's a core component. Actually, the name blueprint is derived because the original creation was blue. It was an easy way to make copies very quickly. And the chemical that made blueprints blue is Prussian blue. Many photographers actually utilize Prussian blue in a process called cyanotype. And since I do not know much about photography, we'll leave it there and get on to the science. For this experiment, you will need iron 2 sulfate or some other source of iron, potassium ferricyanide, glass beakers, a watch glass or an evaporating dish, a scale, paper filters, gloves, and goggles. The first step is to get your iron solution. In my case, it was kind of a waste solution left behind from a previous experiment, so I don't have a clip of me making it. Next, you're going to dissolve your potassium ferricyanide in some water. The next step is simply to add the two solutions together. What you should see is an immediate color change from green to this dark, almost black blue. I'm an idiot and did not get the color change on camera, so what I'm going to do is I took a little container and I'm going to perform the reaction inside of this smaller container so you can see the color change. Upon addition, you should see this immediate dark precipitate form, and we know that's our Prussian blue. It's often used as kind of an iron indicator, and this is why it makes such a vibrant color change and it becomes really insoluble. You can see it kind of likes to stick to itself, and it kind of likes to stick to the container. It is insoluble in water, so it kind of makes an ideal indicator. Just to ensure that all the iron has reacted, I'm going to go ahead and pour the entire stock solution into our beaker. This is a large excess and could be avoided, however, I wanted to go ahead and get rid of all of it. Now in the beaker, it's almost formed a large clump of insoluble material. What I tried to do is swirl it a little bit and break up the large clump, however, it was unnecessary. With our laboratory grade filtration system in place, we're going to filter our solution to the best of our ability. I would recommend performing this experiment with some sort of vacuum filter if possible. For me, it's not possible, so I'm just going to go ahead and use gravity. After multiple water washings, this is what the compound ended up looking like, a large black goop. I decided to go ahead and take a plastic spoon and scrape off the contents of the filter paper onto this watch glass. Now, I'm going to lose some of the product, but again, this isn't really a reaction where we're worrying about our yield. This is what the compound looked like after a few days of drying on a little shelf. It tended to just kind of fall off the watch glass, and it didn't really stick to it, which was great, except around the outside where I imagine would be a large amount of the impurity. The impurity, I think, is some sort of sulfate that was left behind from my waste iron, but again, not really worried about it. It looked like it mostly kept on the watch glass. However, if I wanted to, I could go back and wash it a few more times with water to get all of that out. I figured I would show you a little trick that you can do if you don't have a mortar and pestle on hand. You can take a bottom of a beaker and kind of grind down the powder to get a smoother texture. However, in my case, this didn't work too well. It kind of ended up just scratching the bottom of the beaker too much, and this is why we have mortar and pestles. But it is a good trick for a little bit softer powders. At this point, it had been about 5 or 6 days on a single experiment. I was a tad bit frustrated that this was the problematic part. So I decided to do what any reasonable person would do. I folded up the paper and hit it with a hammer to grind down the large chunks, and then used a beaker to roll around on the smooth powder. As you can see, it worked very well. I would recommend simply using a mortar and pestle though. It saves a lot more time, headache, and hammer marks on your nice lab table. Because the material is slightly light sensitive, I decided to put it in an old medicine bottle. The result is that I synthesized about 5.5 grams of the material, starting with 11.1 grams of potassium ferricyanide and using an unknown amount of iron waste. I would say it's a 400% yield. Joking aside, it was a great experiment and one I really enjoyed doing. Because I made a famous paint, I decided I would try to make a paint out of it. And that didn't work too well because I don't know what I'm doing. However, I was able to find a few resources online that talked about using some sort of linseed oil and making a paste out of your chemicals. However, I don't know where to get linseed oil around here, so I decided to use a little bit of vegetable oil and an old paintbrush. I decided to paint a picture as sort of a greetings to the website that a lot of you have migrated here from, Imgur. The result of this venture was a sign that looked like a child had drawn it. However, it is very interesting nonetheless. Thank you all for watching. If you enjoyed the video, please like or subscribe, or watch some of my other videos if you haven't already. Please be sure to comment down below because I want to hear from you guys, so anything you have to say, I want to hear about it. This is the first video in 2017, so here's to another full year of doing science. I hope you all stay along for the ride.